Okay, very good morning, yeah. We'll start the session.
Yes, sir.
Okay, in the last class, I missed that AVL tree deletion, how AVL tree is working and everything. I missed that. I write the total algorithm on the deletion also. Okay, I write the deletion part. I already tell something about that. Uh, but I will write first of all a simple tree here. Then we will discuss about that algorithm and how it works. Okay. For example, I write one image here. Then after that I went to meeting. Otherwise I will create all the images also. Okay. For example, the BST deletion and everything, the AVL tree deletion is same as BST deletion. We have to perform BST deletion only. That means if it is there are three cases in the BST deletion. The node is maybe a leaf node, maybe it contains one single node, one single child, or else it go for two children. There are three cases we have to perform like BST deletion. Then after that, we have to check what is the balance factor for the each and every node from that, and we have to go up to the root node. And in between that, if there is any node is imbalanced, then we have to go for this thing. Okay, have to calculate balance factor for each
Yes.
node during the backtracking up to the root node. Okay, then we have to perform the rotations if needed. Otherwise, there is no need. Okay. For example, there are two cases. Actually, there are only two cases: left heavy and right heavy. Okay. First of all, I will discuss about this right heavy. Okay, right heavy.
But your screen isn't shared.
Oh, sorry, yeah, sorry. Every time I do the same mistake. Okay. This is the algorithm. Okay, first of all, we have to perform BST deletion and we have to check balance factor for the each node from the deleted node to the root node. And based on the backtracking, then we have to perform. Then we have to check is there any rotations needed or not. Okay, sometimes we deleted, there is no need to rotate anything. Just simply we can leave like that. Why? Because it's following all the AVL trees. For example, if we are deleting any node, we have to go for this case or else it go for the this case. That is going to be left heavy or right heavy. There are only two cases is there. Okay. First of all, I will discuss about right heavy. For example, this is the tree. For example, BST. Okay, and all the balancing factors I am writing here. For 50 it is -1, for 40 it is -1, 45 and all the leaf nodes it is going to be 0 like this. Okay. Then now I have to delete 45. Now I have to delete 45. If I delete 45, then we have to check the balance factor of 50. What is the balance factor of 50 now?
-2.
-2, right? That means if it is a 2, that means if it is a 2 means it is heavy on the left hand side.
If it is 2, yeah, very on
If it is -2, if you observe it, if it is -2, that means right is heavy here. Right is heavy. That means there is no nodes in the left, for example, and heavy thing is in the right hand part. Okay? Understand? If it
Yes,
is
sir.
minus
Yes, sir.
2, then we have to go for right heavy case. Right heavy case. This is right heavy case. Okay? And then, okay. Then I have to check. Right heavy night is. Then that's why I'm going to check what is the what is the right child's balance factor. Right child's balance factor. Okay, then it goes for the right heavy case. Then we have to check right heavy. Now that's why I'm going to check right child's balance factor. There are two cases here. Wait 1 minute. Smell is coming from here, I think. Okay. Okay. Then I have to check here. I have to check what is the balance factor for the right child from the imbalanced node. If it is 0 or if it is negative value, for example, like this, I am going for here. There are two cases. What is the two cases? If the right child has balance factor is less than equal to 0, less than equal to 0, less than equal to 0 means, for example, it is some other node is also here. For example, it is minus 1 also if it is less than or equal to 0. That means there is no need, just simply we can rotate in just left rotation. One left rotation is enough. Okay, one left rotation is enough.
If it
Okay,
is 0 or minus 1.
if it is 0 or minus 1, what is minus 1? For example, what is minus 1? For example, there is another node in the right node of 70. Okay,
Yes, sir. Yes, sir.
that's why I have to go for just simple one left rotation is enough. One left rotation. Okay, if it is 0 or minus 1, if it is 0 or minus 1, okay, then after the rotation, after this rotation, how it will be rotate, only this subtree I am checking. This subtree will be, this
60
is
will become
60 is
the
coming here
root node.
and 50 is coming, and
55 will become the child of
child
50.
of 50. Okay, then this is going to be the 70 only. Okay, now I have to draw like this, the subtree I'm writing, that's it, the subtree I'm writing. Okay, like this. And now this is going to be 60, this is 60, and this is going to be 50, and this is a 55, and this is 55, and this is going to be 70. This is going to be 70. Now calculate what is the balance factor for 55, that is going to be 0, and for 70 is also 0. Then what is the balance factor for 50? Minus 1,
Minus
-1.
1.
minus 1, and the balance factor for 60 is
1.
1. And then the balance factor we have to go for up to the root, na? Then the balance factor for 40 is 1 and 2, it is 2 minus 1, 2, 3 it is. Then it becomes minus 1 only.
Minus 1.
Yes, now it is balanced. Like that, it is going to be balanced. One rotation is enough. When it needs only one rotation, if the right child has 0 or minus 1. Okay, if it is 0 or minus 1, then just simply rotate left is enough, nothing else. Okay, then the next case, for example, in the next case, it is also right heavy. It is also right heavy. For example, there is no 70, for example. There is no 70, for example, there is no 70 actually. Then what is the height of, what is the balance factor of 60? That is going to be 1. Okay.
Well,
Now observe it. Now I deleted 45. 45 is here. I deleted 45. Now the balance factor of 50 is minus 2. Yes. Then I have to check what is the right child balance factor. Now the right child balance factor is,
Right.
that is 1. That is 1. Yes.
1.
If it is 1, if it is 1, if it is 1, that means greater than 0, we have to perform right and left rotation. Right rotation and then left rotation. Understand? Right rotation on child node, left rotation on 50. Okay, got it? Then, first of all, in the right rotation, it will be converted into like this. It will be converted into like this. This is going to be, this is 55. This is 55 and it is going to be 60. Okay. And here there is one node is there after this rotation, after the right rotation. Okay. Then I have to go for left rotation
Left
on
rotation.
50 on 50. Okay. Now it is going to be rotated. Now it is going to be rotated to the left rotation. Now it becomes 55, 50, and 60.
60.
Yes, understand everyone? In this
Yes,
way,
sir.
it is going to be traversed. Got it?
Yes, sir.
Yes.
Yes, sir.
This is right heavy. Right heavy. There are two cases. There are two cases. The right child has 0 or minus 1. The balance factor is either 0 or minus 1. Then we have to go for only one rotation. That is left rotation is enough. Okay. If the child has 1, the balance factor is 1, we have to do two rotations. So first right rotation, then go for the left rotation. Got it?
Yes, sir.
Yes. This is a right heavy case. This is right heavy case. Then I have to go for a left heavy case. For example, left heavy case I will write. There is no time to create the images. I will create here. Then it is going to be. For example, it is 40. It is 40 and it is 30 and it is 20, 20, 35, and it is 10, 20,
25.
22, for example, like that, whatever the value it is. And here it is a bigger value, it is 50 and it is 45 and it is 60, for example. Okay. I want to delete 35. I want to delete 35. I write a box here to delete it. Okay. I want to delete 35. Delete
So 30's balance factor will become plus 2.
35. Okay. Now I have to calculate what are the balance factor of this one. This is going to be 0. And after deletion only, I'm checking that after deletion of 35. Okay. And the
Yes,
balance
sir.
factor of 20 is also 0. And the balance factor for 30 is
2.
2. 30 is 2. And the balance factor for this one is
This
1.
one is 1. 1.
1. And all the balance factor, this is 0. And the remaining value is also 0.
0.
Okay. Now I have to delete 35. Deleted 35. Then after that 30's balance factor is 2. Why? Because here there is no nodes and here there is height is going to be 2. That's why it is going to be 2 minus 0. It is 2. That is imbalanced node. Now we have to check that if it is the 2, if it is 2, that means if it is minus 2, it is right heavy. If it is the 2, if it is left heavy.
Left
Okay.
heavy.
If it is left heavy, if it is left heavy, we have to check. Just observe that. Don't think about any algorithm, how I am writing that algorithm. Okay, how I am writing that algorithm. If it is left heavy, for example, then we have to do either one rotation or two rotation, na? Yes.
Yes, sir.
How I'm writing algorithm? I'm not writing algorithm first and not writing the I'm not doing the next. First I'm preparing the image, then based on that I am writing the algorithm. Okay, got it? We are thinking that formula is invented first, then we are solving the problems. No, not that is not true actually. Based on solving so many problems, they invented a formula. Okay,
Yes, sir.
understand everyone? Yes, like that.
Yes, sir.
Based on the performance we are doing, I am writing the algorithm. Okay. Here, for example, I deleted it. Just think about all the remaining cases also. For example, that means either maybe it is going to be either right rotation only, right rotation only. There are two cases na, right rotation or else
Right, left.
left right, left right,
Sorry, left, right. Yeah.
left
Left,
right.
right.
Okay, there are only two cases. We have to think to that problem first of all. When I have to go for right rotation, when I have to go for left and right rotation, the simple thing, that's it, nothing else. For example, here it is 0, here it is 0 or 1 also. Okay, if it
Yes,
is,
sir.
if it is 0, for
0 or
example, there
1.
is no 22, for example, then it becomes 1 na?
1. Yes, sir.
That at the time also we have to go for right rotation only.
Yes, sir.
Okay, understand?
Yes, sir. Understood.
That
Yes, sir.
means 0 or 1 of child of left child balance factor of left child. Like this I am writing. When I am going for right rotation, I am going for the right rotation, I am going for the right rotation. Okay, when the balance factor of left child is either 0 or 1, either 0 or 1, when I have to go for when I have to go for this left right rotation, tell me everyone, anyone.
Sir, when the child's balance factor is -1.
Yes, it is -1. Give me the example here, give me the example,
Sir,
what node it is deleted.
if we remove 10 from there,
Yes.
10 from
If there is
20,
no
sir.
10, for example, if there is no 10, for example, then it is going to be -1. Then we have to rotate left first, then 22 and 20. Then we have to do the right rotation. Understand?
Yes, sir.
That's
yes,
it.
sir.
That's it. Nothing else. Everything
Sir,
is clear, right? Tell me
so
now.
I assumed, like I recognized the pattern over here. Like when we are doing just right rotation, then at that time we are getting a full chain, like 30, 20, 10. It's a full chain, like in one direction only. And when we are doing left, right, it's not like it's a chain, but it's all of them aren't in the same direction. Like 30, 20, 22.
Hmm. Yes, yes,
They
yes.
one is in the left, one is in the right. So
Hmm.
at that time we are doing left, right
Left, right. Yes,
to
if it is
first
both in the
to
same direction, then we are going like that. Yes?
yeah, yeah, yeah.
That's it. Okay, for example, here some 10 has 10 has children, there is no 20 has children, for example, this tree will be already imbalanced now. Yes?
Yes, sir.
Okay, I'm not going to be confused anything. Yes, it is clear now right now. Yes?
Yes, sir. It's clear.
Only these cases it is going to be follow. These cases only. Okay. To perform BST deletion, just simply we have to delete. That's it. Then we have to check balance factor from that node to the top of the root node. If there is any imbalanced node, then we have to stop there. Then is it 2 or -2? If it is 2, if it is 2, that means left is heavy. If it is -2, right is heavy. Okay. Then based on that, if it is left, we have to check either it is 0 or 1. Whatever it is, we have to perform the left right rotation or right rotation or only left rotation. Got it?
Yes, sir.
This
Yes,
is
sir.
about AVL tree. Okay, this is about AVL tree. AVL tree deletion, that is. Then going for the B tree. Okay, just listen a little bit carefully. Okay. B tree is a binary search tree. It is a binary search tree. But for example, if we go for binary search tree, for example, this is a node. It contains only single value, na? It contains only single value, right?
Yes, sir.
But
Yes, sir.
in B tree, it is not going to be contain a single key value. It contains multiple key values. That's it. Okay. It
Multiple key
contains
values.
multiple values it has. For example, the node we are going to be represent with a rectangle, for example, like array. Okay. Okay, for example, here I am going to take, for example, m is equal to 3. In our syllabus also, the tree is a 2, 3, a 2, 3 tree. That means if I go for 3, if I go for 3, that means every node has two values. Every node has two keys. Okay, if it is 4, for example, if it is I am writing m is equal to 5, for example, every node there are m minus 1 keys. Okay, got it? For every node there are
M
m
minus
minus 1,
1.
1 keys. Okay,
Four keys.
four keys
Okay.
is there. Then what about 5? That means 5 children are there. Okay, first of all, I will tell, for example, m is equal to 5. Then I will come with m is equal to 3 like that. Okay, m is equal to 5, for example,
Okay.
m is equal to 5. But in our syllabus, there is only one tree is there, 2, 3 tree. That means m is equal to 3 only. Okay, I will explain something, some concept to understand the total concept with m5. Then I will go with 3 with the example. Okay, for example,
Sir,
if it
what is M over here?
M means how many nodes, that's it, nothing else.
M
The
means how
order,
many?
the
Child
order, that's
nodes.
it. Some may be treated as a T, some may be treated as N, some may be treated as M. Whatever it is, that's it, okay? That means how
Okay.
many children it has. That means order. That's called, M is called order, that's it. Okay? For example, here, if there is, M is 5, if M is 5, the key values are 4. The key values are 4. Okay? One, two, three, four. In this particular node, if there are elements, all elements are in a sorted way. That is ascending order always. Okay. For example, 10, 20, 30, 40 like that. Okay. Now what is M? M is 5 na? That means now it has 5 children. It has 5 children. One, two, three, four, five. Okay, 5 children. It has 5 children. Okay. 5 children means here I can write a node. Here I can write a node. Here I can write a node. And here also I can write a node. And here also I can write a node. Here also I can write a node. And here also I can write a node. Okay. And it contains again four keys, four keys, four keys, four keys, four keys. Understand?
Yes, sir.
Yes,
That
sir.
means m is equal to 5 means the children for particular node has 5 children and the keys are 4. Okay, got it?
Yes, sir.
I am explaining with
Yes, sir.
only this example. I can explain. It will be understand. I will explain with the 2, 3. Then it will be more clear. First of all, I am telling the concept. That's it. Nothing else. Okay. There are total 4 keys is there. For example, here it is going to be 10. It is 10, for example, and it is 20, and it is 30, and it is 40. Okay. Now I want to insert 5. I want to insert 5. Where 5 is going to be insert means 5 is smaller than 10, then 5 is going to be inserted at this position. Got it?
Yes,
Yes,
sir.
sir.
Okay. For example, I want to insert 15. Where I have to insert 15?
After 10, like after 10,
Here
like
I
on
Five.
the
have
right
to.
side of 10, on the right side
Here,
of 10.
here I have to create. It
Yeah,
is less. It is greater than 10.
greater than
It
10.
is less
Okay,
than.
and
It is less than 20. Na? That's why
20. Yeah.
15 is going to be inserted at this position. That's in this way it is going to be follow binary subsidiary property. Okay. For example, I will go with, for example, 45. For example, I have to insert 45 is greater than this one. Then I have to insert 45 at this place. Got it?
Yes, sir.
Yes, sir.
Yes. In this way, it is going to be followed binary search tree. There are some properties is there, and I will tell you. It is generalization of BST, and it maintains sorted data for every node. All leaf nodes at same level. All leaf nodes at same level. Okay. Insertion is always done at leaf node only. Okay. These are the properties. B tree of order M has following properties. Okay. What it is going to be? This is very important. What it is. Okay. Every node, for example, M, order M. For example, M is equal to 5. For example, M is equal to 5. Every node has maximum M children. Maximum M children. Okay. For every node, there are maximum of one,
Maximum
2,
children.
3, 4, 5.
Five.
Maximum 5 children. Maximum it is not minimum. Okay. Minimum children are for the root node. For the root node, the minimum children is 2. For example, if it is a root node, minimum, if it is a root node, for example, if it is a root node, for example, it has minimum 2 children. One is this and one is this. For example, it has only one value initially. For example, it has only one value. For example, okay, it has 2 children. Minimum, it has 2 children. Okay, then internal nodes, remaining all internal nodes, that is always m by 2, seal of m by 2. Seal of m by 2. For example, 5 by 2, it is going to be 5 by 2, it is going to be
Two.
2.
2 na?
2.2.
2.2.
2.5. Then
5.
seal
Yeah.
it is going to be 3.
Oh, round
Okay?
off.
Rounding off.
Seal it is. It is
To the
2.1
ceiling.
also. It is
Plus.
2.1 also. We have to go for 3.
Yeah, yeah.
Okay?
Oh,
Got
okay.
it.
Okay.
It
Okay.
is a seal.
But the
Otherwise, we can
upper
tell
one.
that. Otherwise, we can tell that like this. There is no seal. It's simply divided by plus 1. Like that also we can write.
Yes, yes.
Okay?
Yes.
We will check all the properties. When we are inserting with the example, we will understand is it following or not. Okay? Every node has every node. This is a particular node. This is a particular node. Okay? This is a particular node. For every node, maximum keys are m minus 1. For every node, m minus 1 means 4 keys are there. Na? Maximum keys are m minus 1 keys for every node. Okay? And what are the minimum keys? What are the minimum keys for root node? We can maintain minimum key is 1. Minimum key is 1. For other nodes, m by 2, m by 2 minus 1. M by 2 minus 1. Okay? Based on these
Yes, sir.
properties, we will work with the insertion. Then you will understand it clearly. Okay? For example, I will go with m is equal to 3. M is equal to 3. I will write an example here, I think. Okay. We will go with this one. Then we have to follow all the properties. If there is any missing, then what we have to do, it will be clear. Okay. Okay. These are the values. First of all, m is 3. M is
3.
3 means in a particular node, there are
2.
two values
Two
only.
keys.
Okay, two keys. Only two keys. Okay. And here there is
3 child nodes.
three children maybe. Okay. Three children like that. Okay. Now I have to insert five. I have to insert five. First of all, here there is no values, nothing is there. Just simply insert 5 at this position. Insert 5 at this position. Okay. Here it is. 5 is inserted like this. Okay. Now it is not a leaf node. Now it is not a leaf node. Okay. 5 is inserted. Where it is? One minute. Any messages are there. Okay. Just a minute. Okay. Now 5 is inserted perfectly. Okay, no doubt. There is no children for this one. 5 is inserted. Then 3 is 3 is inserted. But 3 is not inserted at this place. Why? Because for every node, we have to always follow ascending
Ascending
order.
order.
Na?
Yeah.
Yes,
That's
sir.
why 3 is inserted at this position, and 5 is just moving. 5 is just moving like that. 3 is inserted here and 5 is inserted at this position. Okay, it is moved. Okay,
Yes.
that's why it is always
Yes.
following a sorted order. Then we have to insert a 21. Okay, now I have to insert 21. Is it 21 or 2?
Third childhood.
It is going to be just I have to insert 21. Okay,
Yes, sir.
what happened? Okay, now it is going to be then just observe for going for the insertion algorithm. Then we have to go here. Okay, we can't insert 21 is here. Why? Because it is containing only two, na? Only two.
Yes, sir.
Maximum is it is already
Sorry.
we already working here. Every node has maximum of sorry. Every node has maximum of
M
m minus
minus
one
one.
keys only. That's why it
Yes,
is
sir.
following this one. But I am not going to be insert 21 into this one. Then what we have to do? Okay, now I have to read the algorithm. Okay, uh, find the appropriate leaf node and where the new node can be inserted. Okay, the insert a key node into the node in a sorted order always. And here the overflow is there. Node overflow. That means I have to insert in the leaf node. This is the leaf node. This is only the leaf node here. There is no other leaf nodes. This is the leaf node. Then I have to insert 21 here. Then it becomes overflow. If it is overflow, then we have to find what is the middle element. What is the middle element of the full node with comparing of three nodes. Okay,
Yeah.
and create
Right.
new child nodes. Create new child nodes. Left node contains smaller than middle and like that. How it is going to be? How it is going to be? 3, 5, 21. What is the middle node? What is the middle value?
Five.
5.
Five.
Just simply I'm going to create. Just simply I'm going to create 5 here. Okay, this is going to be 5. Okay, and these two are going to be coming. These two are going to be coming like this. And it is also two part. It is also two part. Okay, and we have to maintain 3 at this place and 21 at this place. Like this we have to maintain. Okay, now this tree becomes like this tree becomes like this. Now this tree becomes like this. Okay, if it is overflow, find the middle key of the full node. Okay, create a new child nodes, two child nodes, and left node contains smaller of the middle key and right node contains larger than middle key. Okay, push the middle key to the parent node. Push middle key to the parent node. It is going up. Understand?
Yes, sir.
Yes. Then 9 is coming. Now 9 is not inserted at this position. 9 is always the new element is always inserted at the new node is always insertion is always
Leaf
done at the
node.
leaf node only. Either this one or this one, not in this one. Okay. Now 9 is coming. Is 9 is greater than 5 or less than 5?
Greater
Greater.
than.
Greater than coming to this position. Okay, then coming to this node. Okay, now coming to this node, 9 is going to be inserted. Yes, there is a space. If there is no space, again we have to do overflow condition. Okay, there is a
Yes.
space. Then I have to insert 9 like
Nine.
this. 9, 9 in front.
And
Okay,
21.
and 21 at this place. Okay, like that I'm going to insert 21 like this. Okay, After
Yes, sir.
9. After 9.
Yes, sir.
What is the next value?
1.
1.
One.
1 is less than 5. Then I have to go for to the
Remove
left
3.
child. Left child of
Left.
5. Then I have to
Yeah.
insert 5 at this
1,
1 at this 1 at this place, and
3.
3 is at this place. Got it?
Yes, sir.
Yes. Then
Yes, sir.
go for the next value, that is going to be 13.
13.
Where I have to insert
13.
13 here. 13 is greater than 5.
Yeah.
Yes, sir.
13 is greater than 5, and I have to insert, actually the 13 is inserted in this node only, like this:
Yes.
9, 13 and 21, like that, na?
21.
But it is a
Yeah.
overflow, right?
Middle. Yeah, yeah.
Then if it is a overflow, what we have to do?
Make the middle key to
Create
the pair.
two. Huh.
Then we have to create, we have to
Two
go
children.
13 to the parent node, 13 to the parent node, okay?
Yeah.
13 to the parent node. Wait, what happened? Then I have to create two nodes. I have to create two nodes for this one, two nodes which is smaller and which is bigger, like this. Okay? I have to create
Yes.
two nodes like this, and smaller values I have to put in front of that as a left value. That means 9 is
Yeah.
coming at this position, 9 is coming at this place, and
21.
21 is coming to this place. Got it?
Yes, sir.
Yes.
Yes, sir.
In this way, we are going to be insert. After the insertion of 13, it is like that. Then, then we have to insert 2.
Two.
2 is less than 5, and
Yes, sir.
Mm,
it is going to be coming
Middle of
here, and it is 1, 2,
2.
and 3. It is a overflow. It is a
Overflow.
overflow. Then what we have to do?
Make to the parent node and 1 and 3 again the child.
Okay, what is happened here? Now it is 2 is going to the top. Okay, just observe here. 2 is going to the top. Don't confuse here. Okay, 2 is going to be the top, and it is converted into two parts, right? It is converted into two parts. It is converted into two parts. For example, I'm writing, okay, it is left child of 2 and right child of 2. There are two parts. The same algorithm, the same algorithm. We have to push the middle element to the root, and we have to create two children for that, which is smaller. I have to put in the left node, and which is bigger, and I have to put as a right node, like this. Okay. Initially, it is going to be like this. But here, now it is like this. 2, the parent node is like this now. The parent node is like this. 2, 5, 13. Is it overflow in the
No,
top
but
or not?
no.
Yes,
Yes,
sir.
sir.
Yes,
Yes, sir.
again it is a overflow. Again it is a overflow. Then we have to find what is the middle element.
5.
5.
5 is the middle element. 5 is the middle element. Then 5 is the middle element. It is the middle element now. And it is containing two parts. And 5 is at this place. Okay. And it has only two children. And it has only two children. That is 2 and 13 only. Okay.
Yes, sir.
One is 2, and which is greater than this one. Okay. And
13.
this is 2, and this
And
is
this is 13.
13 only. Okay. This is 2, and this is 13. I will write every time. Here this is going to be 2, and this is going to be 13. Okay. Then after that, what is the children of 2? What is the children of 2?
1,
1
That is
and 3.
1 and
3.
3. Okay.
Yes, sir.
This is bigger. This is smaller and this is bigger, and it is containing two pots again, and it contains one, and it contains three. Okay. Then coming to the 13, 13 has two pots again. 13 has two
Yes,
pots.
sir.
That is
9,
smaller
10.
than 13 and larger than
Bigger than 13.
13. Okay.
Yeah.
And it contains again two pots, and this value is 9, and this value is
21.
21.
21.
Like that. After the total operation, when the 2 is inserted, the total thing is happened, and the now tree is going to be like this. Got it?
Yes, sir.
Yes. Now after 2, I have to insert 7. Where I have to insert 7?
On the
On the right of
in the right child of 5.
5. Then always it is inserted in the leaf node only.
Ascending.
Okay.
okay, okay. In
It is
9,
always
in
inserted in the leaf
Then
node.
9. It will
then
shift
9
Then
the
7
9.
it
7
It
9
will
is,
7
shift
9
yes,
7, 9.
7
we
9.
have to move 9 to the next location, and here I have to insert 7, and here it
Mm.
is going to be 9. Got it?
Yes, sir.
Yes,
Then
sir.
at 10, I have to insert a 10 now. Where I have to insert a 10 now?
Um,
Sir,
either
it
either
should
on the
be
7, 9 or 13.
Huh? It is greater than 5.
5.
It
Yeah.
is less than 13. Na?
7
That
9.
7,
means
Yeah.
here 7,
Overflow.
9,
9,
and
10.
10.
10.
It will
Like
create
this, we have to
overflow.
insert, but it is a overflow condition. If it
Yes,
is
sir.
a
Yes, sir.
overflow condition, we have to divide we have to find the middle element, and we have to push to the root node. Okay.
Yes, sir.
Then we have to make two children. We have to make two children, left case and right case. Okay.
Mm.
That means
Yes, sir.
here I am going to write. Here I am going to write. What is that? For example, 9 is going to be the root node. Okay. And it has two parts. It has two parts. Okay. Then what is the value here? It contains two parts. For example, I'm writing. Okay. It contains two parts. It contains two
9
parts.
7 10.
And it has like this. 9 is going to the root node. 9 is going to the root node. And here it is 7, and here it
And
is
10.
10.
10.
Okay. But 9 has to be go to the root node. Na?
Root
9 has
node.
to be go to the root node. Yes, there is an empty space is there, then there is no problem, right? Then we can insert it, but in the ascending order we have to insert it.
9
Okay.
and 13. Yeah.
Now 9 is coming to this place. Okay. And 13
Sir,
is
root
coming.
node over here is the just parent.
Yes, yes. Root node means the parent. It is moved to the parent, not root node. It's moved to the parent, and we have to erase this link. It is greater than 13. Na? It is greater than 13. Okay. Now I have to link like this. Okay. Now I have to link. I have to link instead of this one. Instead of this one, I have to link these two. Got it?
Yes, sir.
Yes, sir.
I have to link to here and to here. Got it?
Yes, sir.
In this way, it is going to be inserted. If it is full, 7, 9, 10, it is full. 9 has to be moved to the parent. Here also, if you observe it, when 2 is inserting, 2 is inserted to the parent node. It's parent node. Already parent has 5 and 9. Yes? When it is inserting 2, if you observe it. Yes?
Yes,
Yes,
sir.
sir.
Yes. Then, after that, after what element we inserted? 10,
We
na?
inserted 10, now 12.
12. Now
Then
12.
we have to insert 12. Then we have to insert 12. Where I have to insert 12 here? It is
Sir,
greater
In the
than 5.
On the right
10
node of 9
9.
after 10.
Then I
after
have to
10.
insert, just simply I'm going to insert in the order that is going to be 12 like this. Very simply we can insert it. Then 4, where I have to insert 4?
Sir,
On
on
the 3
the
node
right side of
of
2.
3.
3.
Right side.
After 3.
After 3 we
Yes.
can insert here. There is an empty space. That's why I'm
Yes.
inserting. Otherwise it is not possible. Okay.
Yes.
Then
Yes.
where I have to insert 8?
On the
Sir,
right side of
on
7.
the right side of 7.
Right side of 7. That's it. That's it. In this way I am going to insert the values. Understand?
Yes, sir.
After that, for
Yes.
example, I want to insert 25. Where I have to insert 25?
Sir, on
One
the right
second.
side of 21.
Here
21.
I
Yeah.
am going to insert 25, for example, like this. Now, for example, I want to insert 30. Tell me now.
30.
I can go with any number of any numbers here, na? Yes, I
Yeah,
have
yeah.
to insert 30 now. What operation it will be done? Just explain me.
We will make 25 the parent node.
Yes,
Yeah.
here.
30 will first of all form an overflow
21,
condition. So,
25, and 30. Yeah.
yeah.
For
21,
example,
25, 30.
30 I have to insert, it is a overflow. Why? Because 21, 25 and 30
25,
it
30.
is. Then we have to move 25 to the parent node,
Parent
Parent
node.
node.
25 to the parent node. Okay. And I have to make two children of 25,
20.
21 and 30.
21 and 30. Okay.
Yeah.
Then it is finished. But then again,
But
is the parent node
again, one
is
more overflow
Yeah,
condition.
no,
we
no.
again have to make 13 the
Now,
parent node. Yeah.
Then we
13
have
in
to
the
move
parent node
13 to the parent node.
after 5.
After 5.
Understand?
Yes,
Yes.
sir.
In this way, we have to insert it.
Yes.
Got it?
Yes, sir.
This is
Yes, sir.
about insertion of B tree. Just the algorithm. The main thing is this one only.
Yes, sir. The overflow condition is the
The
main.
overflow
Otherwise,
condition only.
all
Otherwise, we can
everything
insert
else
it
is
now. No
pretty.
problem.
Yeah.
Yes, is it clear?
Yes, sir. Yeah.
Yes, sir.
Take one example of your own. We can take our own examples also. We can create automatically our table. Okay.
Yes, sir.
Yes.
For example, here I am going for 6. It is become okay. Okay. It's always coming. The less numbers is there na in the left hand side. It is not possible. Okay.
Sir,
Tell me.
after B tree, what are the things that are left for our course from our course?
Third unit is completed.
Third is completed. Fourth is left.
Fourth I have to start tomorrow.
So on Monday,
Not
can
Monday.
you
Not
like
Monday. I can finish.
do a recording or something because I will not be present, so I will watch
I,
that
I will. I will
recording.
create it. I will create it. No problem.
Okay. Okay. Thank you, sir.
Okay, right? Then we have to go for deletion in B tree. Okay. It is a little bit tricky. Not that much tricky. Just simply okay. I'm deleting everything. Delete. Operation delete is little bit than insertion. Okay. This is the key. Don't first of all don't read any algorithm. Okay. We have to first of all we have to work with one example. Then if you read the algorithm, it will be very clear. Okay.
Okay, sir.
Then at that or else we can go with parallelly what the case it is, how we have to use it and everything. Okay, I will write some content. Maybe I write sometimes it is not understandable in the other time. Okay, like that I will write. I will not again recollect it. Okay, that is my main problem. Okay, I have to write a diagram. There are number of cases is there. There are two cases actually. There are two cases. Uh, if the target key is a leaf node or an internal node, there are only two cases is there. If it is a leaf node or an internal node, okay. Other than thing is
Yes,
it
sir.
is very easy. I work with this example only. With this same example, no? 1, 2, 3, 9, 13. Okay, yes. For example, it is in a leaf node. First of all, we are going to be cover the first concept. Okay, the leaf node contains more than minimum keys. Just delete the key. Here we have to check that when we are inserting it, we are checking that is there any space is there. If it is overflow, we are going to the next operation. Na? For example, here also the minimum keys. What is the minimum keys here? Minimum keys for the root node is 1. Okay,
One.
One.
and the other nodes is m by 2 minus 1. For example, here I am using 3 by 2, 3 by 2, what it is? 3 by 2 minus 1. Seal of 3 by 2 minus 1, it is 1 only. It is 1 only.
One,
Okay,
one.
seal of it is 1 only. That means minimum keys, that means definitely it is going to be 1. Minimum is 1 for
One.
all the nodes. No problem, nothing is there. Okay, and the deletion. For example, our target node is, for example, a leaf node or an internal. Leaf node means 1, 3, 4, 7, 8, 10. These are leaf nodes. And the internal nodes is 5, 2, 9, 13 are the internal nodes. First of all, I will go and delete 8. Okay. I will go and delete 8. What happens in the delete? Just simply we can delete it. What it is going to be? The leaf node contains more than a minimum number of keys. Just delete the key. That's it. Okay.
Yes, sir.
I am going to delete 8. Just simply I can delete it. Okay. Nothing else. Same like BST sometimes. Okay.
Yes, sir.
For example, if it is a leaf node and it has, for example, if I want to delete 12 also, I can delete directly. If I delete 4 also, I can delete directly, not a problem. Okay. For example,
Yes.
I want to delete 1. I want to delete 1. I want to delete 1. Okay. It is delete 1, for example. It is delete 1, for example. Then the leaf node contains minimum number of keys. Already it has only one value, na? It has only one value. If I want to delete it, what I have to do? Just simply the leaf node contains minimum number of keys. Okay, then I have to delete it. I have to borrow from immediate left node sibling if possible. Okay, if possible I write like that, or borrow immediate right node sibling if possible. Okay, first of all we go with
Yes.
2a or 2b. Okay, what it is, for example, I want to
Two B.
borrow, for example, I want to delete it, delete one, and I have to borrow from the
Right.
immediate right node.
Right
Immediate
node.
right
Yeah.
node.
Two
Right
B. Yeah.
node is only right node is there. There is no left node if you observe it.
Yes,
Yes,
sir.
sir.
Okay, there is no left node here. That's why I go for right node. In the right node, for example, it has more than number of keys, minimum number of keys. Then only we can borrow. Otherwise, we can't borrow it.
Yes, sir.
Okay, but it has two keys. That means minimum value is 1. It is greater
Yeah.
than minimum number of keys.
Minimum
Then
values. Yeah.
we can borrow from this sibling, but directly
Yes.
we can't borrow it. Directly we
Yeah.
can't borrow it. We have to swap. What is the minimum value from here? I have to swap to this, and I have to swap root to this one. Got it?
Okay. Yeah. Yeah.
Yes, sir.
We have to
Three
swap
and
these
two.
values. 3 is going to be coming this value, and 2 is
And two.
going to be coming here. In
That's
this way,
right.
we can borrow. Borrow means like this. Okay. Now it
Yes.
is
Yes.
following a B tree. Okay.
Yes, sir.
Understand?
Yes, sir.
Yes, sir.
Understood.
I will go to the game. Then, for example, 10 I am going to delete. 10 I am going to delete. How I have to delete a 10? Directly I can delete 10, na? No problem, right?
Yes.
Yes, sir, we can directly
I
delete.
can
Yes.
directly delete 10. For example, I want to delete 12 now. I want to delete 12 now. But this node has already minimum values. If I want to delete, I
Yeah.
can delete
It
it.
will borrow from left.
For
Left
example,
side.
from the right, is it possible?
No, not
No,
No,
sir.
possible.
not
It
possible.
will borrow
Then I
from the
have to
left. Yeah.
check from the left.
Left
Then,
side.
Left.
if I want to go for
The
left,
9 will come
then
down
I
and
have
8
to
will
take
come
maximum
Eight
up.
value.
will go to up. Eight will go high.
Understand? If I'm taking
Yes.
from the left node, I have to take the maximum value. If I'm taking from the right node, I have to take the minimum value.
Minimum value. Yeah.
Got it?
Yes, sir.
Yes, sir.
Yes. Then 8 is going to be swap and 9 is going to be swap. Here it
Downward.
is
Yeah.
going to be 8
Eight.
8,
and
And here
here it is
nine.
going to be 9.
9.
Nine.
Like that, we can delete it. Got it, everyone?
Yes, sir.
Yes, sir.
Yes, like this. Okay. Now, this is up to this is cleared. That means I borrow from immediate left and I borrow from immediate right. Both is completed, na? Yes.
Sir. Yeah.
Then the last values, for example, I want to delete 9. I want to delete 9.
Okay.
Is it possible from the left or right?
No, sir.
No,
No,
not
sir.
at all possible. There is a case. Then what I have to do? Merge nodes with any of the sibling, any of the sibling. Okay?
Yes.
Either this one or this one we can merge with that root node. Okay. For example, I will tell you the two things. I will merge with right and I will merge with left also. I will explain. Okay. First of all, I have to merge with these two. For example, with the right child. With the root node, I have to merge. Then it becomes a 9, 13, and 21. Got it?
9:30. Wait a minute.
Yes,
Like
yes.
we are merging with the root and the root's right side.
Yes, yes, yes.
Oh,
Okay.
okay, sir.
Yes.
Then I forget about it. That's why merge the nodes with the sibling. Okay, then what we have to do? Uh, have to delete 9. Na? Okay, sorry, I have to delete 9. 9 is already deleted. 9 is already deleted. Okay. Then first of all, I have to merge. First of all, I have to merge the nodes. First of all, I have to merge the nodes. Okay. I have to merge the nodes with the root node. Then I have to delete it. Then I have to delete it. Then just simply I'm going to create like this. I will write
Okay, they will form a leaf node of with
leaf
by
node.
their
That is
values.
13 and 21. That's it. This is 13 and 21. Like this.
Yes, sir.
Got it?
Yes,
Like
sir.
this, we are going to be merge with the root node. For example, I am going to merge with left node. For example, I want to merge with left node. Then it is going to be, then it is going to be 7, 9, sorry, 8 and 9. Then 9 is deleted. Then it becomes just simply I'm going to delete these two. Just simply I'm going to delete these two, and 8 is also deleted. Then it has only single node. Then it is going to be 7 and 8. Okay, got it? It is going to be contain 7 and 8. I will write perfectly. Here it is going to be 13 is left. It is going to be 13 is left. 13 is left. And it has a minimum. and it has a maximum. It has a maximum. And it is going to be 21. And it is going to be 21. And it is going to be
7.
7 and 8.
Yeah.
And it is going to be 7
7
and
and
8.
8.
Like this. In this way, delete is happened. We have to merge. We have to merge with any of the sibling. Any of the sibling is that one. Understand? Like this. Initially,
Yes.
the graph is the tree is like this. Okay.
Yeah.
If the tree has, we are deleting the leaf nodes only. All these are I deleted the leaf nodes. Only three cases is there. If it has a number of nodes is not a minimum value, then we can delete it directly. Not at all a problem. Okay, for example, here I want to delete 4, I can delete
Yeah, we
it,
can
not a
directly
problem.
delete it.
Directly
Yeah.
delete it.
Directly.
For
Yes, sir.
example, I want to delete 1, I
No,
have to
we have
borrow
to
from
right
right
side.
Borrow
or
from right
left.
side.
Uh,
If both are
GG.
not possible, we have to merge with any one sibling. Understand?
Yes, sir.
Yes, sir.
Yes, that is about leaf node deletion. Leaf node deletion only. Okay.
Yes, sir.
Yes, sir.
Then I have to delete. I have to delete with internal nodes. I have to delete with internal nodes. Uh, the same. I have to go back again. This is the thing, no? I have to delete 3. You can delete it.
Internal, so I guess 9,
Delete 2, for
32.
example. I want to delete 2, for example, now.
Okay.
Okay. I want to delete 2 or 13 or 9, whatever it is. Okay. All are internal nodes. 5 is also internal node. I want to delete 2, for example. Okay. I want to delete 2. Then it is an internal node. It is an internal node. Yes, yes. Ma'am, completed in 20 minutes. Okay. If the target key is an internal node, replace in order successor if possible is everything. Okay, if case is there. Okay, otherwise replace with in order predecessor. Okay, that is also not a problem. Okay, these are the first
Yes,
two
sir.
cases. Or else if both the above two cases are there, if the above three cases are failed, if above all are failed, all are these things coming. Okay, first of all I am going to cover each and everything. First of all, replace with in order successor. In order successor means, for example, I want to delete 2. If I want to delete 2, just observe here, I want to replace with in order successor.
Successor is 3.
Successor is 3. Successor, in the successor, for example, in this node, it has more number of keys, right? That's why if
Yes, sir.
possible, I
Yes,
mention
sir.
if possible. Na? If possible means it has more number of keys, minimum number of keys. That's why it is possible. For example, can I get the value from the in order predecessor? Is it possible? No.
No,
No.
sir.
For example, the in order predecessor is 1. If I remove 1, that means it is empty. That's why I'm not going to be
It will be
take from
left
the in
empty.
order predecessor. I can take only from the in order successor. Why? Because it has a maximum value. That's why I'm going for this one. Now, just simply I'm going to delete 2 and I have to replace with 3. Got it? Yes, 3
Yes,
is
sir.
also deleted from here. Okay? 3 is deleted. That's it. Like this, we can delete it.
This is the first case.
This is the first case.
Parent node deletion. Yeah.
Insert 2 and insert 3. For example, again, I will delete this 2. I will delete this 2. I will ask you a simple question here. 3 is inserted and again I delete 2 here. Again, I will delete 2 here. Okay. Now I insert 2. Where I have to insert 2?
Uh,
On the
right
right
side
side
of
of
one.
one.
Right side of one. Yeah.
No, yeah. I have to insert 2. 2, only
Okay,
2.
three. Three will shift to.
Ha. No, 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 no. On the right side of one
But
only.
the insertion, huh? Leaf node, na.
In leaf
Where
node.
I have to insert 2? Again, I'm asking.
Two. I,
One, two, like one and then
ah,
two.
Left child, left child.
Yeah.
yeah,
Right side of
yeah.
like
Right
right
side
Yeah.
side
of
of
one.
one. Matlab, I
Okay.
mean to say in
Yes?
the left
Manually
side of
wala,
three
huh?
and on the right
Okay.
side of one.
Got
Right
it,
side
got
of
it.
one. Yeah.
Right side of 1. Okay?
Yeah. Yeah.
Got it, na?
Yeah.
Now,
Yes, sir. Yes, sir.
now I have to delete 3. Is it
Delete.
possible to get in order predecessor? In order successor?
Yes, and no,
In
not
No,
order
no, it's
successor,
not
but
possible.
predecessor.
a predecessor
Predecessor.
we can get in order predecessor. That's why. Okay.
Yes.
Now it is going to be deleted 2 and it is going to be 2 here. Got it?
Yes, sir.
That is the case
Yes.
of in order predecessor. Either one or anyone. For example, if both are available, we can go with anyone. Sometimes both are
Okay.
available. Na? For example, I want to delete 9. I can take either from 7 and 8 or else from this node and this node, right?
Yeah.
So it's
I- I-
like in BST when there are two values, right? It has
Just
two children.
two children.
Yeah.
But here we have to satisfy it has to be more than minimum value. Then only we can take it.
Yeah, that's
Okay.
true. Yeah.
Yes, sir.
That is the only small addition of the BSC. That's it. Okay.
Yes, sir.
Now this 12 and 13. Okay. First of all, I'm going to delete 12. I'm writing different cases to satisfy all the values. Okay. For example, the tree is like this. 12 is not there. 12 is just deleted like that. Okay. Now I have to delete 13. Now I have to delete 13. What is the 13 in order successor is 21, but it has only minimum value. And the
Only
in order
minimum, yeah,
predecessor
not more
also
than
it has only one minimum value. It is
minimum value.
not at all
Okay.
possible. Okay.
Yes.
Then we have to go for case 3. If above two cases are failed, merge left and right subtrees. Left and right subtrees. If the above 3 cases are failed, merge the left and right subtrees and borrow from the whatever it is. I will write some content. Okay, first of all, we have to merge left and right subtrees. Okay, I have to delete 13. I have to delete 13. Okay, I have to delete 13. Just simply I'm going to delete 13. I have to merge these left and right subtree both and I have to make into a one node. That's it, nothing else. One
Nine,
node,
it
9
they will
and
like they will become the right node of nine,
Yeah,
right?
10 and
13 is
12.
deleted.
Yes.
Yes. Like that, it is going to be 21 and it is totally deleted. It is totally deleted. Then it is the right child of 9. That's it. In this way, we can easily work with that. Got it?
Yes, sir.
Like this. And 3 and 2. Delete 3 is already deleted. 3 is already there. 3 is already deleted. Then I want to delete 2. Okay, now. Yes. Now I want to delete 2 from this. I want to delete 2 from this. Just observe here. This case is
Two
different.
from this.
If it is 13 is
Yeah.
deleted, if 13 is deleted, I can merge 10 and 21. Na? I can merge just
Yes. Yes.
simply
Yes, sir.
10 and
10,
21 and
21.
I can write as a 9 right child.
Right node.
But
Right.
here,
Yeah.
is it for if I merge 1 and 2, for example, if I merge 1 and 2, but here there are no nodes.
Sir, we are
Okay.
deleting two, right?
Just simply if I delete 2,
Sir,
there,
this.
there is if there
Okay.
is any keys here, that is not a problem. We can merge these two. That is not at all a
Yeah.
problem, right? At this case, Yet this case, if the above three are failed, for example, merge left and right subtrees. Okay,
Borrow
that means we have to
from
merge these two. We have to merge these two. Okay, then
And they can become.
borrow from left or right sibling, left or right sibling. Okay, from this,
Okay.
for example, I want to merge these two. First of all, I am going by step. I want to merge
yeah.
these two, then it becomes 1 and
One
4.
four.
One
Yeah.
and
Then
four.
it becomes 1 and 4. This is going to be 1 and it is
One
going to be
four.
4. Okay,
Yes, sir.
that means it is deleted. It is deleted. Okay, and 2 also
Yes.
I deleted. Now 2 also I deleted. For example, I want to
Yes,
merge
sir.
these two. Then after that, merge left subtree and right subtree, then borrow from the left sibling or right
Let's see.
sibling.
Let's see.
For example,
Right
here
sibling.
the right sibling has, we can take one value na, we can take one value. Okay,
9.
then I have to swap
Okay, shift
9
from
here
five. Five. Yeah,
and
yeah.
5 is
Ah.
coming here. Okay, got it?
Okay, okay, yeah. Yes,
Just
sir.
like we
Yes.
did before
The
for your
leaf node.
leaf
Huh.
trees,
Leaf.
leaf
Yes,
nodes.
it
Huh.
is going to be coming like this. Now, 5 is going to be coming to replace this one, and 9 is coming to the root. 9 is
Yes,
coming to the
and
root.
five.
9 is coming to the root, and 5
Yes,
is coming to this position. Okay.
yes, sir.
Now I have to remove this, and I have to make it as like this, and it is like this. Got it?
Oh, so nines. Okay, yeah, it makes sense. Nines left
Understand
child
now?
got removed and it got attached to 5. Yeah.
Right? That is
Yes, sir.
this
Got it.
case,
Yes, sir.
fourth case. Understand now?
Yes,
Yes,
sir.
sir. Yes.
Yes. For example, if I want to delete 5, for example, the same thing in a different cases.
Five.
If I want to delete 5, is it possible to, for example, I want to take, yes, it is possible. Not just simply I can take here, just simply I'm going to delete before that. I want to make that value. No 4 is there and no 8 is there, for example. Okay. No in order
Okay,
successor,
sir.
no in order predecessor is there. Okay.
Yes,
Now
sir.
I can't take in order predecessor, in order successor. Okay. Then I have to merge these two. Can I take borrow from the sibling? Can I
No,
No,
sir.
borrow?
no,
No,
Yes,
that
no,
is
no,
also not
no.
no.
possible. In the
We will have
previous
to merge
example,
that
it has
two as
two
well.
values. That's why I can take it. Now I can't take it now. Yes,
Yes.
Yes, sir.
I can't take borrow from this one also. Then what we have to do? Then that is the last case. If all above fail, that is the last one. Merge the two nodes and merge sibling with parent. Merge sibling with parent. First of all, merge two nodes. That means these two nodes we have to merge. That means it
One
becomes
seven.
1 and 7. It becomes
Yes,
1
sir.
and 7. It is 1 and 7. And 5 is already deleted. 5 is
Yes, sir.
already deleted. Then after that, merge
9 and
sibling with
13.
parent. Merge sibling with parent. This sibling
Sibling
with the
13
parent.
and 9. Yeah.
Okay?
Yes,
Merge
sir.
sibling with the parent. Then it is going to be like this. Then 13
Oh,
is coming here. It is going up. It is going up. That's it. Nothing else. 13 is coming here. It is not pasting it there. 13 is here. 13 is here. Then
13 is also deleted from there.
after that, this is greater than like that. Got it?
Okay. Yes, sir.
In this
yes,
Yes.
way,
sir.
it is going to be working. Understand?
Fives box got fives. Yeah, fives box got completely out of got removed completely out of existence. I can say like the
Yes,
file.
yes, yes. Okay. In this way, I want to delete all the five cases. I write all these five cases. Okay. I will share for all these five cases. I will share every image to you. What I'm writing here. Okay.
Yes, sir.
Okay. Then again practice it. Then you will
Sir.
understand more clearly how it is working. The same example I'm taking, but a little bit changes to cover all the cases. Okay.
Yes, sir.
Yes, sir. This
Understand?
is one of the most interesting
Yes. Yes.
Yeah.
structures.
Yes.
Data structure. Yeah.
Yes, it is working in building of data structures, sorry, databases. Building of databases it will be used. B-tree is very important when we are working as an SDA roles like that. So many examples is there for B-tree. Most interesting and most difficult to write also. Okay.
Yeah, that's why like
Yes.
it's
Yes.
pretty like, understandable
And
that its code will be
if you
regarded.
want to improve the coding skills, just simply go to the lead code. Uh, just open the lead code. Just simply go for. Don't try. We are at initial stage. So many are don't know how to practice on lead code. Okay, that is the main problem. See, some students. Oh, here it is not there. I will. Okay, I will continue here. Okay, just simply the one thing. Is it audible?
Yeah, yeah, it's
Okay.
audible. Sir.
Sir. Yes,
Okay.
sir.
You are
Yes.
audible.
Uh, so many are thinking that just simply go. They are selecting some question. So they are selecting some question like this. Okay. Just they are reading the question. They are reading the question, and it will not understand, or else sometimes the question will be understand, and they think about at least 5 to 10 minutes. They are thinking that 5 to 10 minutes is a very big time. They are thinking like that. Okay.
Sir,
And after,
sometime it takes hours.
yes, yes, that's why I'm telling.
Hours.
If it is 5 to 10 minutes, and after that
It's
they want to
nothing.
write, and they didn't write, then directly they are going for solution and they are searching for
Yeah.
the solution. Okay, and they want to write the best case, the best algorithm always. First of all, don't think about any algorithms, whatever in your mind, just don't think about any algorithm. First of all, first of all, for example, you wake up at 5 o'clock or 5:30. In Indian time, it is available at 5:45 every day. The new question will come at 5:45. Okay, just simply read
Yeah.
the question in the early morning. Read the question. Don't do it. Don't do it. Any programming like don't do it. Just read the question. Okay, and understand the question. It will take 10 to 15 minutes only. That's it. Understanding the question. Okay, just
Yes, sir.
Yes,
close the
sir.
laptop and go to the college and totally work on all the things. Okay, if there is one or two friends is there, here group of people is very important. Okay, then if you have any free time in the classwork, just discuss about, don't about solution. The question is like that, the question is like this, just think about the, discuss about the question. Okay, or else if there is no friends, discuss with you only. What is that question? Again, recollect the question. That's it. Nothing. Just recollect the question when you are free, when you are doing lunch. If you are practicing it, if you are sleeping also, your mind will work. If you are sleeping also, your mind will work. Okay. Then there is a automatically the plan will, some plan will be there.
Pop up
Don't
in
think
your
about
yeah.
any algorithm. Just try to write a brute force question. For example, I want to check with this value with all the elements in the list. For example, write the exact code what is in your brain. Just try to write it. Okay, it is there. It is done for all the test cases, or sometimes it is give, for example, a TLE. Okay,
5 minutes, yeah.
Okay,
That is the worst.
then go for
Yes, sir.
topics. Then go for topics. Now you can understand. Okay, this problem we can have to solve with a two pointer or string or dynamic programming. Okay, that means maybe a two pointer solution is there. If you want to think about it. Otherwise, go to the solutions. Now, after working of 7 to 8 hours thinking about that, initial days, I am telling the initial days. Okay, if you are not solving at all, just some editorial is there. In that, sometimes you are not giving. So, okay, for example, like this, they will give some theoretical concept also. Okay, approach. Read that approach. Don't go directly go for the solution. What is the code? Just read if anyone is giving some content about the approach. Okay, they are giving so many are going to be give this way we have to do this day we have to do. Don't go for directly code. Okay, maybe it is possible. It is possible with the algorithm. Is it possible or not? Try to write implement this algorithm. Yes, sometimes we
Yes, sir.
can't solve one question 1 week also. If you want to write your own, read different algorithms, invest time. Okay, don't think that 6 hours is very big for solving the question. No, don't think like that. Okay, so many are beginner mistakes. What the mistakes we are doing? I am telling that they are going for problems. For example, everyone in an imaginary, I need a very big package. I want to solve very good problems. They are thinking that just they are going for arrays like that. Okay, and they solve some easy problems, 10 to 15 easy problems, and directly, and then they are thinking that, oh, yes, I'm very good in every program, in the easy program, just directly I will go with some hard problems. For example, 2 pointer I will take, and they filter with the difficulty is going to be hard. Don't go like that, yeah. Don't go like that. Okay.
Easy, medium, hard.
First of all, if you are going for any topic, first of all, try to implement that algorithm in easy problems. That algorithm in easy problems. Okay. Then, first of all, I will show you. I will show you how many easy problems I solved. 364. I solved easy problems. Okay, I solved 99 only medium. Now I am focusing on medium. I'm not focusing on any hard or anything. From last 1 month, I am focusing on medium only. I leave this lead code 3 years back. Now I'm starting now. Yes, I have a very good knowledge on easy problems, how to implement small algorithms for the easy problems. Now I am working on medium problems. Do like that. Okay. If you are
Yes, sir.
very strong, just simply there is a hashing or summation or dynamic programming is there, for example, here. It's a very vast concept. It is backtracking is a very big concept. Go and solve easy problems of dynamic programming first. But when you are coming to the easy problems, we can solve without dynamic programming concept also we can do it. That's
Yes,
why
sir.
we
Dynamic
are.
programming just like it makes it more efficient.
Yes, if you go for any easy problem in the dynamic programming without going to the without implementation of dynamic programming also we can solve it. But you have to solve that easy problem with DP. Okay, then go for the solution here. For example, if you don't understand how to write a solution in the dynamic programming, just go here and click on here and how they are solving it. Okay.
Yes, sir.
Don't copy and paste it. Don't copy and paste. How they are writing one problem, yes, then go for the related problems here. Similar questions is there. Yes, then go and try that similar problem. Okay, one student
Yes,
is
sir.
there. One student is there. She solved 150 problems. In 150 problems, she solved nearly 120 problems are medium problems. Okay, she's telling that, sir, if I saw a new question, I'm not able to understand how to solve it. Why or how it is possible? You already solved 100 questions, 150 problems, easy problems. Why it is not coming? I asked a question like that. She is telling that, sir, I solved all 150 medium problems to with the solution
Through
only. I
solutions.
solved the solution, then I
Uh,
copied and I understand it. That's why. Don't go for always solution. The beginners, you are a beginner. If you are not able to run it, just you have a basic concept. It first of all, think about the question for 6 to 7 hours. Then practice how to write a brute force code for that. Then, if it is working or not working, if it is working TLE, then go for the solution and read the algorithm. Don't go for the code. Read the algorithm, how they are doing it. Then you will understand what is the approach. Okay, then try to implement it. If it is not implemented, if there is any minor cases is going, then go for the solution. What are the what then adapt it to like you only. Okay, like that we have to work on the coding. Yes, so much. The minimum time we have to give to expert in coding is 1.5 year. I know that. But we are thinking that it is in 1 month or one day. It is not at all possible, yeah. Okay. Here, consistency is very, very key. Okay. Consistency is very, very important. We are
yes,
doing
sir.
10 questions in single day. The next month, we are not going to be touch any single program. That is not at all good. At least in the starting days, go for simple problem. Go for just simply go with problem of the day. Yeah. Problem of the day is enough. Every day, whatever the situation is, just go for problems here. There is a problems here now.
Yes, sir.
In the problems here like that, if you click on that, today's question will come. Read the question, and discuss with the friends. Nothing else. Nothing else. How to solve? How to solve? How to solve? That's it. Nothing else. Got it?
Yes, sir.
But we have to implement in reality. Then only result will come. Okay.
Yes, sir, we will.
We can speak so many things. In the imaginary, we can do so many things, but in reality, we can't do anything. Yes,
Yes, sir.
make it a habit to do one program daily. That's it. Whether it lead code is best, I think.
So yes, lead code is the best. Like
Best.
it will also highlight your profile. Like it will also become a highlight in your
So many
profile, and
companies direct
it will.
questions from the lead code only. So
Yes, sir,
many questions.
directly lead code. And in fact, they
Do
check your
any form.
profile on lead code. Like most of the
Yes.
big companies, big tech
Yes.
companies, they sometimes check your profiles on lead code. But yeah, this